Good day, everyone. Today we're going to discuss all about earthquakes. By definition, earthquakes are natural geologic phenomena caused by the sudden and rapid movement of a large volume of rock. The violent shaking and destruction caused by earthquakes are the result of rupture and slippage along fractures in Earth's crust called faults. The point at the surface directly above the focus is called the epicenter. During these large earthquakes, a massive amount of energy is released as seismic waves. It is a form of elastic energy that causes vibrations in the materials that transmits them. Seismic waves are analogous to waves that is produced when a water droplet is dropped into a calm pond. Mainly, we have two different causes of earthquakes. The first one is man-made. This instance also refers to induced quakes, which are caused by human activity, like tunnel construction, filling reservoir, and implementing geothermal or fracking projects that cause the ground to shake. The second was earthquake caused by natural phenomena. This includes constant movement of tectonic plates called as tectonic quakes. They are accounted for most earthquakes worldwide and usually occur at the boundaries of tectonic plates. Another natural cause of earthquake was volcanic eruptions or volcanic activisms. They are generally not as powerful as tectonic quakes and often occur relatively near the surface. Consequently, they are usually only felt in the vicinity of the hypocenter. Moreover, the main mechanism of an earthquake was the energy released by atomic explosions or by the movement of magmas on Earth's crust can generate earthquake-like waves, but these events are generally quite weak. Here is a deeper explanation about earthquake. The actual mechanism of earthquake generation eluded geologists until H. F. Reid. Reid concluded that tectonic stresses acting over tens to hundreds of years slowly deform the crustal rocks on both sides of a fault. When deformed by differential stresses, rocks bend and store elastic energy. Slippage allowed the deformed or strained rock to snap back to its original stress-free shape. The springing back was termed as elastic rebound by Reid because the rocks behave elastically. The vibrations we know as an earthquake is generated. Let us now move on to foreshocks and aftershocks. Strong earthquakes are followed by numerous smaller tremors called aftershocks that gradually diminish in frequency and intensity over a period of several months. In contrast to aftershocks, small earthquakes called foreshocks often precede a major earthquake by days or in some cases by several years. So, foreshocks are the energy released and the ground shaking before an earthquake, and aftershocks are the energy release and ground shaking after an earthquake. Foreshocks are less likely to do damage than aftershocks because they are smaller in magnitude. Let's discuss about earthquakes and faults. Let us first know the relationship between earthquakes and faults. So, earthquake takes place along faults both new and old that occur in places where differential stresses have ruptured the Earth's crust. Some faults are large and capable of generating major earthquakes. This includes strike-slip earthquakes which occur on strike-slip faults, normal earthquakes that occur on normal faults, and thrust earthquakes that occur on thrust or reverse faults. One of the best examples for this is the California San Andreas Fault, which is a transformed fault boundary that separates two great sections of Earth's lithosphere. The fault extends roughly to 1,200 kilometers. Now let us talk about the study of earthquake waves, which is called seismology. Seismologists use the aid of seismograph in recording about earthquakes. These data are called seismograms and are generated because of the internal disturbances or movements called earthquake waves. They provide useful information about the nature of seismic waves. Seismograms reveal the two main groups of seismic waves. It is a surface wave and body wave. But how does seismograph works? Seismographs have a weight freely suspended from a support that is securely attached to a bedrock. When vibration from an earthquake reaches the instrument, the inertia of the weight keeps it relatively stationary while the earth and the support move. It is referred to as surface waves because their motion is restricted to near Earth's surface. Body waves are divided into two, primary waves or P waves and secondary waves or S waves. Body waves are identified by their mode of travel through intervening materials. P waves are push and pull waves. They momentarily squeeze or push and stretch or pull the rocks in the direction of the waves. P waves can travel through solid, liquid, and gas. On the other hand, S waves shake the particles at right angles to their direction to travel. S wave can only travel on solid materials. The motion of the surface waves is somewhat more complex. As surface waves travel along the ground, they cause the ground and anything resting upon it to move, much like an ocean tossing a ship. In addition to their up and down motion, surface waves have side-to-side motion which is more destructive since it particularly damages the foundation of a structure. Next thing we will discuss is locating the source of earthquakes. The first thing that seismologists analyze in an earthquake is its epicenter. The method used for locating an earthquake's epicenter relies on the fact that P waves travel faster than S waves. Since P waves travel faster than S waves, there is an interval upon the arrival at the seismic station. The interval is encoded in helicorder, a device which records signals from a seismometer. The greater the interval of the time of arrival from the first P wave to the first S waves, the greater the distance from the epicenter of the quake. Seismograms are essential to conduct triangulation method. On a globe, a circle is drawn around the seismic station. The radius of these circles is equal to the distance from the seismic station to the epicenter. The point where the circles intersect is the epicenter of the quake. So this is how triangulation works. Let us now determine the size of an earthquake. Commonly, earthquake is measured by two scientific scales, the intensity and magnitude scale. Intensity measures the observable damage that an earthquake had caused, while magnitude measures the amount of energy that an earthquake released. The most common intensity and magnitude scales are Mercalli Intensity Scale and Richter Scale respectively. The modified Mercalli Intensity Scale measures intensity. It was named after Giuseppe Mercalli, who initially developed it in 1902. This intensity scale is divided into 12 levels of severity based on observed effects. However, these have drawbacks. This scale is based only on the observed shaking of the ground and not on the energy released. The next one is magnitude scales. The most notable magnitude scale is the Richter magnitude by Charles Richter in 1935. Due to this, Richter used logarithmic scale to express magnitude, in which tenfold increase in wave amplitude corresponds to the one of previous magnitude scale. The most dependable between the two is the magnitude scale, since it measures what we intend to measure, which is the amount of energy released by an earthquake. Also, intensity reading varies from places to places, specifically between developed and underdeveloped places. However, in the recent years, seismologists have come to favor new measurement called moment magnitude. Seismologists and other experts believe that moment magnitude is much reliable than Richter scale. This is because it measures the average amount of slip, the area of fault surface lift, and the strength of the faulted rock. This is all for today. Thank you for watching.